Okay, so a vertical translation is your up-down. Any number that's on the end, that's going to be a vertical translation. So right here next to vertical translation, I'm going to put up 5. Okay. The horizontal translations will be in the exponent. So if it says plus, it goes to the left. If it says minus, it goes to the right. So this one's going left 4. Okay, so if it says minus, it goes to the right, plus goes to the left. A stretch or compression would happen if there was a number here. There's not a number there. There's just like a negative sign. So there's no stretch or compression. If there was a 2 there, that would be a stretch. If there was a 1/2 there, it would be a compression. So anything in between 0 and 1 is a compression. Anything bigger than 1 is a stretch. Negative signs are going to be reflections. So there's 2 types of reflections. There's a reflection across the x-axis. So if this is your x-axis, it reflects it this way. And then this is your y-axis. So a reflection across the y-axis is this way. So this is like a horizontal reflection, and this is like a vertical reflection because it's reflecting it across the axis. So a reflection across the x-axis happens when there's a negative sign in front of everything. So like in this one. So we're just gonna say like yes for that, or just like a check or something, whatever you wanna put. There is a reflection across. Here, we're going to say no, there's no reflection across the y-axis. A reflection across the y-axis would be if there was a negative sign or a -1 in front of the x, like that. So if you look at the second one, see how there's like a -x there? So for number 5, I'm going to say yes to that one, because there's a reflection across the y-axis, so it's going to flip it this way. So going back to this one, the 4, that's going to translate this down 4. So that's a vertical translation down 4. You see how there's no like numbers up here, it's just an X. So that means that it's not moving left or right at all. So there's no horizontal translations. So there's nothing being added or subtracted to the X. We do have a number in front here, so it's a 0.5. Since 0.5 is in between 0 and 1, that's going to be a compression. So I'm going to put compression there.
Because is it in between what?
In between 0 and 1, like a fraction. And then this is not negative, so that means there is no reflection across the x-axis.
Okay, so a compression is like in between 0 and 1, and then a stretch is...
Yeah. So things like compressions are like those, stretches are like stuff like that. Okay, next one. So next one we are solving. So for the first one, I can solve using the one-to-one property because 5 and 25 can be written with the same base. 5. Now, I don't really have to rewrite this one because it's just 5. So I'm just going to leave that one. But on the right side, I'm going to write 25 as 5 squared instead. So that they both have that base of 5. It is possible that you'll have to write both. So maybe like if this is 125, you'll write 5 cubed on the left and then 5 squared on the right. Then we're going to multiply our exponents together. So we want to multiply 2 and x minus 7.
So 2x minus 14?
Yeah. You can do that in a separate step or the same step as once you have 5 to the stuff equals 5 to the stuff, you can just take stuff and stuff and set them equal to each other. That's the one-to-one property. If this is a different number than this, you can't do that. So that's why we couldn't just do that at the beginning. Because they were different bases. You only do it when they're the same base. So we can do it now because they're both 5s. Just subtract 2, and that's it. X is negative 14. The end. If you want to check your answer, you can use a calculator to just plug back in your X and make sure that those two things are equal. So you could type in 5 to the 3 times negative 14 power, and then 25 to the negative 14 minus 7 power, and they should be the same thing. All right, let's look at B. So 6 and 42 can't be written with the same base. So even though 6 times 7 makes 42, that's not like an exponential thing. In order for us to write those as the same base, it would have to be 6 squared, which is 36, and that's not 42. So when you can't write them the same, when you can't write them using the same base, you have to use logarithms. So your exponent's going to be with a certain base, and that's what we're solving for. Whatever this base is, you want to use a logarithm with that base to get rid of 6. It would be nice if we could just divide by 6, right? We can't divide by 6 because this isn't multiplication. So that's why we need logarithms. So what we're going to do is put a log with a base 6 in front of that 6. And so what we can do now, because of the power property of logarithms, is this will come down and not be an exponent, and these two things cancel out because log base 6 of 6 is 1. So that's the inverse operation. So if this was a 5, we would use a log base 5. If it was a 10, we'd use a log base 10. If it was a 7, we'd use a log base 7. And whatever you do to one side, you have to do to the other side. So the other side needs the same logarithm. This logarithm we'll use a calculator to figure out. So before we do that though, we need to just subtract 4 from both sides to get x by itself. Don't combine the 4 with the 42, because this isn't a 42. This is a log of 42. So keep these separate, especially when you plug it into your calculator. So make sure it looks like this when you plug it into your calculator. And let's see what that is.
2.086. Oh,
It's
yes,
fine,
sir.
it's fine. He's fine.
I said, oh, what up, guy?
Trying to hold too many things.
I said, oh, what up, guy?
I got something different. I got negative 1.91.
Yeah, 1.91.
Yeah, I got 1 up.
So it says round to 3 decimal places when necessary, so there you go. In general, if you're talking about money, please don't round to 3 decimal places, round to 2 decimal places. Right?
For
So
years too, right?
years you can do 3 just for the sake of getting the answer. Alright, so there we go. Make sure the 4 is outside the parentheses.
I was just telling you the log 6 one too. I wasn't saying that.
Oh, yeah. Alright, questions? No, for sure.
Did
I
you give
have
that
another one.
shit?
Yeah, yeah.
Oh, what up?
Okay.
That's good.
I said, oh, I'm going to God University.
Alright, let's go to 3.
Still long talk to my family and friends.
Alright, so with number 3, we're going to use our log properties to condense logarithms as much as possible.
Oh, divide these bad boys.
Yeah, so since this is a minus sign, we can divide this by this using the same log. So log, and then in the log we're going to divide x plus 2 by 3. Whatever comes first goes on the top, and whatever comes second goes on the bottom. And we're dividing because it says minus. If it says plus, we
Multiply.
multiply. Okay. Now on the right side, I'm gonna turn this 2 into an exponent. So instead of 2 log x, it's gonna be log x squared instead. Your goal is to get 1 log on one side, 1 log on the other, or 1 log on one side and then maybe just a number on the other. But like 1 and 1. You don't want multiple things. So you're condensing all the way. Now, what is the base if you don't see it?
10.
10.
10. So I'm just going to put a 10 there so you remember that that's base 10. Once you condense, then you have to somehow get rid of the logarithms.
Put a base of
So
10.
you're gonna use a base 10 because the base of the log is 10. So kind of like what I was showing you with this. Since this was a 6, we use a log base 6. Since the log is base 10, we're gonna use a base 10 exponent. And by doing that, these cancel and you're left with x plus 2 over 3. These cancel and you're left with x squared.
Now you multiply by 3 on both sides.
Now you have to solve what's left. So in this case, because we're dividing by 3 here, we would multiply by 3 and get x plus 2 equals 3x squared. And this is a quadratic equation. So we want to get everything on one side
So subtract by 2
and also x.
and x.
Make it equal 0.
Or couldn't we just do, would it be easier to just do minus 3x squared?
You can if you want. I like to keep my x squared positive in case I want to factor,
Yeah.
but you can do that if you want.
So it'd be negative 2 and 1.
You want to put, well, it's not that simple when you have the 3 there. So you want to make sure it's in descending order, and then it's up to you if you want to use the quadratic formula or factor. What do you want to do?
Quadratic formula.
Quadratic
Oh,
formula?
Factor.
I can do both. I'll do both.
This factor.
So to factor, you first have to multiply 3 times negative 2, because the 3 is there. Then you're making a list of all things that multiply to 6, and you want to pick 2 that add to negative 1.
No. Okay, so
Negative
negative 3 and 2.
This one, negative 3 and 2.
bottom one.
So we're going to rewrite this using these 2. So we have 3x squared plus 2x minus 3x minus 2. So you're just using these
I
two
see the
numbers
quadratic
instead of
formula.
this
Yeah.
guy. You can use the quadratic formula if you want. Okay, now, so you see what I just replaced those for negative 1x. Now we're going to factor by grouping.
Of course.
So for this group, what's our greatest common factor?
X.
Yep. That gives me 3x plus 2. And then for this group, what can I take out?
Negative 1.
Negative 1. Yeah, so when there's not a number that you can take out, remember you can always take out a 1. If this is minus, it's always going to be minus. And that switches the sign here. So we have 3x plus 2. So our two factors are going to be x minus 1 and 3x plus 2. After you
So-
factor, what do you do?
It said equals
So-
0. Both them, both here.
So x equals 1, and then,
Oh, okay, so it's gonna be.
And then,
so it'll be 3 over negative 2.
no, negative 2 over 3.
Or negative 2 over 3, sorry.
After you get your answers, you want to plug them back in, make sure they work.
Number 1 works.
This works
And
because when you plug it back in,
Yeah.
everything's still positive. But
Negative 2 over 3 does not work.
when you plug this in here, it makes a negative logarithm, which is not good. So that one doesn't work. It's extraneous. Okay, so we're going to cross that one out. If you use the quadratic formula, then A is 3, B is negative 1, and C is negative 2. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So this is 1 plus or minus, this is positive 1. When you multiply these together, so this is 12, and then times 2 is 24, and since they're both negative, we're going to add. this is gonna be the square root of 25, which is 5. So you have 1 plus 5, which is 6, divided by 6 is 1. Then you have 1 minus 5, which is negative 4, over 6, and that simplifies to 2/3. So that's quadratic formula way. But you'll see we get the same answer no matter what. Okay. So personal preference. Questions?
Wait, so when you plug it back in, you're plugging it back into the original.
Yeah, like this.
Yeah.
Yeah.
It basically it works if it's keeping everything positive.
Yeah, if it keeps what's next to the logarithms positive, then it's fine. If it's making them negative, it's not fine. Okay, so we're going to start this one the same way. We're going to try to condense. Now, we would just start with the plus sign, but since there's this number here next to the logarithm, I need to turn that into an exponent first. So I have log of 2 plus log of x plus 3 to the 1/2 power equals 1. Anything to the 1/2 power is a square root. So we're going to rewrite this as the square root of x plus 3. Okay, so you have to remember that 1/2 power means square root. 1/3 power means cube root. Okay, so fraction exponents are radicals. Now, we'll put these two logarithms together. Since there's a plus in between, we'll multiply them. So we'll have log, and then 2 times x plus 3. So like 1 log multiplying the 2 and the square root of x plus 3 together. We've pretty much done all we can do as far as condensing now. Okay, so we're like done pushing things together. What is the base of this logarithm? 10. Otherwise it'll show something there, like a 2 or a 5 or a 7. Once we're done making everything condensed, we're gonna get rid of the logarithm using whatever base this is. So in this case, a 10. These are gonna cancel and you get 2 root x plus 3 equals 10 to the 1, which is just 10. I didn't record any of that. Dang it! Alright, these are the ones that you need to know your formulas for.
Yay. Pert.
There's 2 main formulas.
You have pert?
I have a question.
You got PERT, and then you got the other one.
Oh, do we also need to know the carbon K one or no?
It's the same thing.
Yeah.
Okay. So you need to know those 2.
I really want coffee.
Sure. Alice invests $4,000 into an account that earns 3.5% interest compounded monthly. Monthly is a key word there. How much will she have in 10 years? If it says monthly and not continuously, we're using this one. So we use this one for monthly, daily, quarterly, annually, semi-annually,
Time.
any kind of lee that's not continuously. Okay. Monthly would be 12 times per year. Daily would be every day, so 365. Quarterly, think how many quarters are in a dollar?
4. 10.
Annually is 1, semi-annually is 2. Like a semicircle, there's like 2 semicircles in a circle. Okay? Those are just a few. Those are like the most commonly used ones. So since it says monthly, that is referring to n. So all of these are n's. So when it says monthly, we now know that n is 12, because it's happening every month. Because she invested $4,000, that's what she put into the account at the beginning. That's P, the principal. And it says it earns an interest of 3.5%. You want to move the decimal place twice to the left and turn that into a decimal rate. And 10 years is a time. So this is our equation.
Oh, that's it.
That's it.
Let's plug in some stuff. So principal is 4,000. Then we have 1 plus the rate over n to the n times 10. Everything's filled in except for p of t. So I'm going to put p of 10, or the amount after 10 years. That's what we're solving for. So we're solving for this. Now, when you're solving for like what all of this is equal to, then all you have to do is just type this side of the equation in to your calculator, and that's it. So all you're doing is calculating all of this. So you're gonna carefully plug in 4,000 times 1 plus 0.03 over 12 to the 12 times 10 power. If you've never done this in class, please don't let the test be the first time you type it in a calculator. Okay, so if you've literally never typed this in a calculator, do it now so that you can practice. It's not as easy as it looks. And since this is money, I'm rounding to the nearest cent, so 2 decimal places.
Do that later.
Dollar sign goes in front of the number.
Do we need to turn our book up Monday too?
Question on the test where I'm giving you a formula. So I'm going to give you this formula.
Oh, you got
The only reason I'm giving it to you is because it's a depreciation question, and I want to make sure that you are paying attention to the word depreciate. Depreciate means that it's going to go down in value, so you need the minus sign there with the R instead of a plus, because it's not increasing. So it says Ben bought his BMW for $75,000, and it depreciated at a rate of 10.5% per year. When will his car be worth $55,000? So the original amount is $75,000. We want to know when it's going to become $55,000. So the $55,000 is your P of T, or the amount after a certain period of time. We're solving for that time. So we don't know time. We do know the rate is 10.5%, so that's going to be 0.105. Yes. You were probably sleeping. It's from like section 2. Alright, so the first thing you're going to do is divide.
Hey, what's up?
So you're dividing by 75,000.
It's 11 over 15.
At the same time, probably a good idea to simplify 1 minus the 0.105 to like one number. It just makes the rest of it easier,
How did you do this?
because I did it in first period. Huh?
Simplify.
Yeah, I just simplified what's in the parentheses.
Just give that a sh-
You just multiply that?
No, I thought it'd be like easy.
So now we're trying to solve for t, but I have this here, and it's not multiplication, so I can't divide it. So I need a logarithm.
Yep.
If the base of the exponent is 0.895, what kind of logarithm do I want to use?
Huh?
8,
There's different points.
A log with a base 0.895. That's what I need to use. So I'm going to log base 0.895 both sides. I know it's a weird looking logarithm, but that's what we need because that's the base of the exponent. So on the left, I have log base 0.895 of 11 over 15. And then on the right, this log and this base cancel, and I get t, which is what I'm trying to solve for. So that means basically I'm done. I just need to type in this on my calculator and see what that actually is.
I got
Wait, are you sure we've done this before?
you. Yeah.
We did it before, like, we did logarithms, and we used the calculator to solve, but now we know how to do it with logarithms. 2.796 years. So Ben's car will be worth 55,000 in about 3 years.
Are we gonna do one with appreciation or for increases in value or no?
I mean, this is an appreciation.
That's true.
That's an appreciation.
See.
Maybe.
Get out of here, carbon.
Yeah, this isn't like going down. Some of them are decay, some of them are growth.
I have a question. So like what if you asked us to write it in words? Do you want us to write like as a decimal or you can round it off to 3 years?
It's up to you.
Okay.
Okay, carbon 14. I am promising one carbon 14 question on your test.
Easy.
Oh,
Okay, so make sure you know the carbon 14. Got it? Okay. It says carbon 14 content of an old bone was found to have 20% of that in living animals. How old is that bone? And then it tells you the half-life of carbon 14. They give you the half-life so that you can find R, the rate of decay. So, natural log of 1/2 divided by half-life is how you find R.
Yes.
So, our half-life is 5,730 years. That's how we're going to find R. So again, you just take the natural log of 1/2. It's 1/2 because it's half-life, and then you divide by that time that they give you with half-life. That gives you R.
Negative.
So when you type that in your calculator, it gives you a weird decimal. You need to know how to take that decimal out of scientific notation. So this is what it looks like on my calculator. Okay, that's what it looks like on my calculator. What it means is this times 10 to the -4. So you have to take your decimal and move it 1, 2, 3, 4 to the left, which means we would add 1, 2, 3 zeros. So -0.000121 is what I'm gonna round to. I'm gonna round here. That's our R.
Yeah, I have a question. So, did you want our calculator to be in what float? Because mine, I'm like in float 6, and I got.
Get out of float 6. Just put it in float.
Okay.
We already did that. Why is your calculator going back?
Here's
You
the
gotta make
stats.
sure you put it in float and then make it your default.
We're still gonna reset it.
Alright. Does anyone have questions on this? Because I don't want you to get to the test and use this as your rate. Because if you use this as your rate, it's gonna be like so incredibly wrong.
Wow.
Does this not make sense to anyone? Me?
Good.
Okay. Once you find your rate, then you're gonna answer the question. So we've already used this. Okay. Now we're gonna answer the part, it says that it's got 20% of that compared to living animals. So, like separate thing here.
Whoa.
When it was alive, it had 100%. Now it only has 20%. It's decaying at this rate, and we're gonna calculate T.
So divide by 100.
So you always start, with carbon 14 when it's alive. Okay, so it's alive, fully alive, 100% carbon 14. And then it's gonna decay to some sort of percentage. That's why this is 20. Then when you divide by 100,
0.20.
you'll get the basically decimal version of this.
And then you have to use a logarithm to get rid of e.
Yes, and then you'll have to use your natural logarithm to get rid of e. So
Just ln.2.
ln.
So it's gonna be 9.2 equals -0.000125.
Divide that.
And then you'll divide by that big K, this guy. So your time, or the age of the bone, is the natural log of 0.2 divided by 0.000121. Gonna be pretty old.
Okay, so you're using 20 because that's the amount that it has left?
Yeah.
Okay.
Yeah, so whatever it has left, that's what you use. So 13,301 years, 0.140 if you're rounding to 3 decimal places. Okay. So, like I said, I'm guaranteeing one of these on your test, so at the very least, memorize how to do it. Even if you don't fully understand. Questions?
So for the second part of for that problem, it's just the same thing as. Didn't we
It's,
do a-
we're using
yeah,
PERT.
yeah.
Yeah, we're using PERT. Yeah, I forgot to put that up there.
Q.
Why?
Someone's quarterback.
Did you divide
Yeah.
mine?
Because we're trying to solve for t, and it's this number times t. So we're going to divide so that this becomes 1, and we get t by itself. Ready for the next one?
No.
No. Last one. John invested all of his savings, a total of $500, into a stock when he was 22. He wants to know, if his interest rate was 6% compounded continuously, after how many years will John's money double? So even though this is a money question, similar to the one that we did over here, since it says continuously, we're going to use PERT. So when it says continuously, you use PERT. Got it? What is his initial investment? 500.
Also double, so equals 1,000.
And then what is the rate?
6%. So
0.06.
Yeah. What is the time?
Don't know yet.
We don't know yet. That's what we're trying to find. And then what goes over here?
1,000, because it's double.
So it's 1,000 specifically because we're looking to see when his money will double. So we're multiplying 2 times 500 to get 1,000. What if it says when will his money triple?
By 3.
Multiply by 3.
50,000.
Alright, so step 1 is to,
Divide 1,000 by 500.
yep, so divide everything by 500.
Why is there a T on the left side?
This isn't a T, this is a P of T. And it represents the amount you get after a certain period of time. Which for us is 1,000, because we want to know how much time it will pass before he gets double his money. Okay, after you divide, you use the natural log to get rid of e. So I get the natural log of 2 equals 0.06t.
And then divide both sides by 0.06.
Yep.
And then it comes out to around 11.552.
So on your calculator, you'll do natural log 2 divided by 0.06 and get approximately 11.552 years.